Solving a quadratic by the square root method lends itself to some pretty easy situations, which include when you don't have a linear term, which means we don't have this bx value here. You can also use the square root method when your equation is written in vertex form. Some situations you don't want to use the square root method are when you do have a linear term. So right here we have a 2x. And you also don't want to use it if it's in like standard form with a b value or in factored form. Because if it's in factored form, you can just easily set those factors equal to 0 and solve for your intercept. The only exception is if it's in factored form and the factor repeats itself. So let's look at an example of how to use the square root method. Over here we have y equals 10x squared minus 70. We can use the square root method because we don't have a linear term. The first step is to set our quadratic equal to 0 because we're trying to find the x-intercept, and that occurs when y is equal to 0. We want to get x squared alone, so the first thing we have to do is to get rid of the negative 70 or move it to the other side of the equation by adding 70 to both sides. Now we need to get x squared alone by dividing both sides by 10. 70 divided by 10 will leave us with 7. Now we want to take the square root of both sides. When you do that, don't forget to include the plus or minus. Now we see that our solution to this equation is x equals plus or minus square root 7. So we have two different x-intercepts on this graph. Let's look at another way we could have solved this problem. We could have subtracted the 10x squared first instead of adding the 70. Now we want to get x squared alone, and we can do this by dividing both sides of our equation by negative 10, and that will leave us with x squared equals 7. Just like the last time, we want to take the square root of both sides, and we're not going to forget to include the plus or minus. So we see that the answer to this equation is still x equals plus or minus square root 7. So let's look at what that means and how we can check our answer. So by saying we solved this quadratic by the square root method and finding that our solutions are x equals plus or minus square root 7, that means that we have an x-intercept at positive square root 7, 0, and another x-intercept at negative square root 7, 0. We can also check algebraically that we did this correctly by substituting in what we think x should be into our equation and seeing if y really is 0. So let's do that, starting with positive square root 7. So notice I substituted square root 7 in for x, and I put parentheses to show that I was substituting. When we simplify this, the square root of 7 squared is just 7. So we see that we have y equals 10 times 7 minus 70. 10 times 7 is 70, so 70 minus 70 is 0. So we verified algebraically that when x is square root 7, y is 0, which means that that solution is correct for an x-intercept. Let's look at when x is negative square root 7 and see if we also get y equals 0. So when we substitute in this negative square root 7, when you square that, you're going to get just positive 7. And again, we see that y equals 0, so we know we did our work correctly. Here's another example that lends itself to being solved by the square root method because it's in vertex form. So let's look at how we can solve this. We need to first set our equation equal to 0 because we're solving for the x-intercept. There are two steps that you could take next. You could either add the 2x plus 1 squared, that whole thing, to the other side, or you can just subtract 8. I chose to subtract 8 from both sides, so now I need to get the negative 2 to the other side of the equation, and I can do that by dividing because we have negative 2 times quantity x plus 1 squared. Note that a lot of people try to distribute the negative 2 into parentheses, but you can't do that because that stuff in parentheses is being squared. So you must divide by negative 2 on both sides. That leaves us with 4 is equal to quantity x plus 1 squared. Now that we have the quantity squared alone on its own side of the equation, we can take the square root of both sides. And when we do that, we're going to remember to include the plus or minus. So we get plus or minus square root 4 equals x plus 1, and the square root of 4 is 2. So we get plus or minus 2 equals x plus 1. So now to solve for x, we just subtract 1 from both sides. There are two ways to show that, and I'm going to show you both of them now. Usually what mathematicians do is to put the negative 1 in front of the plus or minus. So negative 1 plus or minus 2 equals x. But if you wrote plus or minus 2 minus 1, it's the same thing. So when we say plus or minus, that means we have two different possible solutions. We either have negative 1 plus 2 is equal to x, or negative 1 minus 2 is equal to x. So let's solve both of those to find our x-intercepts. So we find that our solutions are x equals 1 or x equals negative 3. Which means on the graph of this parabola, we have two x-intercepts, one at negative 3, 0, and the other at 1, 0. Let's verify this algebraically. From substituting in our values of negative 3 and 1 in for x, we see that both of them will give us a y value of 0, which means that we solved correctly. We're going to look at one last example to solve by the square root method. we're going to set our equation equal to 0, and then we want to get the quantity squared alone, and we do this by dividing both sides by -1. 0 divided by -1 is still 0. Then we need to take the square root of both sides, and the square root of 0 is 0. So we're going to write that down and then solve for x. And we can solve for x by subtracting 5 from both sides, so we can see that our solution is x equals -5. In other cases, we've seen that we've had 2 different real solutions, but in this case, we just have 1. So let's see what the graph of this looks like. We have a touch and go parabola where it just comes up, touches the x-axis, and goes right back down, instead of a crossover where it crosses the x-axis and comes back down. So we only have one solution, and let's make sure that we did that correctly by subbing in -5 and seeing if we get an output of 0. We do, so we know we're correct. So don't forget, when you're solving by the square root method, we're looking for either an equation that's in vertex form or an equation that doesn't have a linear term. And those would be really good cases to solve by the square root method. One of the biggest things to remember when you're solving by square root method is to not forget the plus or minus.